right, let's do one more example of solving rational equations. This is example number 3 in 6.6. And then in the next video, I'll have you guys try some. So in example number 3, it asks us to solve. So remember, anytime we have a rational equation, we have to look for our domain restrictions. So looking at A, it looks like we have three fractions. We have 1 over 1, 3x over x plus 2, and then we have a negative 6 over x plus 2. And so for our denominators, if this x plus 2 is set equal to 0, then that means our domain restriction is anything except for x cannot equal negative 2. Oh, that's an ugly 2. This is supposed to be a negative 2. All right, so that's our domain restriction. So we just have to make sure that neither of our answers are negative 2. Here we go. Let's go ahead and get a common denominator. And so as soon as our denominators are the same, we can just worry about our numerators. So it looks like my last two fractions already have the same denominator. So it just means that the first one will need a denominator of an x plus 2. So let's multiply both the top and the bottom of that first fraction by an x plus 2 so that all my denominators are the same. That leaves me with this equation now. And since my denominators are the same, we can just set those aside and worry about now just working with our numerators. So we now have a new equation that says that we have an x plus 2 plus 3x equals negative 6. Because as soon as our denominators are equal, then our top should also be equal as well. All right, let's finish this equation by combining like terms, subtracting 2 to both sides, dividing by 4, and we end up getting x equals negative 2. But uh-oh, wasn't that our domain restriction? We said that x could be anything except for negative 2. And since our only answer that we got was negative 2, then we have to say that this actually has no solution because the one solution we got was an extraneous solution. It's going to give us a 0 in our denominator. So actually this equation has no solutions. Always make sure that you double check that so that you don't accidentally say x equals negative 2 works. All right, let's do B. I have three fractions in B. It looks like the first denominator has an x minus 5, the second denominator has an x plus 5, and the last denominator is an x squared minus 25. But can't that actually be factored into a difference of squares, into an x minus 5 and an x plus 5? So if I set all those denominators equal to 0, we have a few domain restrictions. X can be anything except for positive 5 or negative 5 because we don't want zeros in our denominator. All right, now let's make sure that everybody has a common denominator, the same factors. It looks like the first fraction is missing an x plus 5. So I'm going to multiply that fraction by x plus 5 on the numerator and denominator. It looks like the second fraction has an x plus 5, but it's missing the x minus 5. So let's multiply the numerator and denominator by that. And the last fraction already has both of those factors, an x minus 5 and an x plus 5. So that fraction seems like it's good to go. So now that my denominators are the same, I can just worry about my numerators, making sure I distribute this 3 through, making sure I distribute this positive 1 through, and I can make my own new equation now that looks like this, and I can solve that equation. Distributing my 3, distributing my 1, combining my like terms, so 3x plus 1x is 4x, 15 minus 5 is 10, and that's all equal to 0, not 0, 2, sorry about that. I can subtract 10 from both sides. I can divide by 4, and I end up getting x equals negative 2. Remember, make sure that that's not part of your domain restriction. And since negative 5 and 5 were our only restrictions, then x equals negative 2 should work and make that equation true. Let's do two more. In example number 3C, it looks like we have three fractions. We have this one, we have a 2x over 1, and then we have this fraction here. So looking at our denominators, it looks like our denominators right now are x minus 2, 1, and x minus 2. If I set any of those equal to 0, it looks like my domain restriction would be x cannot equal 2. Can be anything except for positive 2. All right, let's get common denominators. It looks like the only fraction that's missing a common factor is this middle fraction. So I'm going to multiply both the top and the bottom by the factor of x minus 2. So that way everybody has a denominator of x minus 2. Since our denominators are the same, I should be able to take and just work with the numerators. That leaves me with an x squared plus 3x minus 1 is equal to the 2x times the x minus 2, and then a positive 11 minus x. Make sure that you distribute your 2x through into the parentheses here. Let's go ahead and combine some like terms. And let's go ahead and move everything to the same side. When I did that, and I moved everything to the same side of the equal to sign and set it equal to 0, I ended up getting an x squared minus 8x plus 12. It's a quadratic equation. That's why I moved it over to the same side and set it equal to 0. That way I can solve by factoring. This looks like a basic factoring problem, so I can find numbers that multiply to 12 that add to give me negative 8, which are negative 2 and negative 6. I can set each of those factors equal to 0, and I end up getting x equals 6 and x equals 2. Now, let's double check those domain restrictions. It told us before, we knew that x cannot equal 2. So, since one of my answers is x equals 2, we know that's an extraneous solution, and the only solution that would work for this equation would be the x equals 6. Not x equals 2, just the x equals 6. All right, last one, and then I'll let you try some here. It looks like this has 3 fractions, all of them with different denominators. Before we start to find common denominators, it's probably the better idea to factor each of those denominators. Remember, first find your domain restrictions, and then let's get a common denominator. So factor all 3 of those denominators. You should end up getting an x plus 3 and an x minus 2 for the first denominator, an x minus 2, x plus 2 in the second denominator, and an x plus 2 and an x plus 3 in the last denominator. If I set all of those factors equal to 0, then I have a few domain restrictions, right? X can be anything except for negative 2, negative 3, and positive 2. So keep those 3 numbers in mind. X can be anything except for positive and negative 2 and negative 3. All right, here we go. Let's keep solving. Let's make sure that everybody has a common denominator, so let's look for factors that are missing in each denominator. In the first denominator, I have an x plus 3 and an x minus 2, but it looks like I'm missing an x plus 2, right? In the middle denominator, it has a minus 2 and a plus 2, but it looks like it's missing that x plus 3. And in my last denominator, I have a positive 2, a positive 3, but it looks like I'm missing an x minus 2. Remember, when you multiply the denominator by those missing factors, you also have to multiply the numerator by those missing factors to keep your fraction balanced and still equivalent. Now I have a common denominator, don't I? All denominators have the same factors. And since my denominators are equal, then I can just worry about my numerators. So looking at my numerators, it looks like I have a 4 times the x plus 2, a negative 1 times an x plus 3 is equal to 2 times an x minus 2. Don't forget about that negative sign in the middle there. Let's go ahead and distribute the 4, the negative 1, and the 2 so we can finish solving. Let's combine like terms. A 4x minus 1x is 3x, 8 minus 3 is 5, and that's set equal to 2x minus 4. I'm going to subtract 2x to both sides, and I'm going to subtract 5 to both sides, and I end up getting x equals negative 9. Now we had a few domain restrictions, didn't we? X couldn't equal positive 2, negative 2, or negative 3, but x can be negative 9. So it looks like we have our final answer there and no correlation or overlap with those domain restrictions. Whew, those are a lot of steps for each of those problems, and any little mistake is going to ruin everything, so you've got to be really careful with all that you do. So I'd like you to watch the next video of the try it problem. Give yourself some time to try these 3 problems, making sure that you know how to solve these rational equations by getting your domain restrictions, by factoring to get your common denominator, and then making sure you solve and check your answer. Watch the next video for the answers to these try it problems.